This is Chapter 5 of our AZ-204 journey. The focus now is monitoring, troubleshooting, and optimization in Azure. Even though this area has the smallest weight in the exam, only 5 to 10%, it is still critical, because no application can succeed without visibility into its performance, cost, and health. Why is monitoring important for developers? Because when something goes wrong in production, logs and metrics are often the only way to find the root cause. Mini review. Monitoring in Azure means collecting logs, analyzing metrics, detecting issues, and optimizing performance. What is Azure Monitor? It is the central service for collecting, analyzing, and acting on telemetry from cloud and on-premises resources. What data does Azure Monitor collect? Metrics for numerical performance indicators, logs for detailed events, and traces for code execution. What tools are part of Azure Monitor? Application insights, log analytics, alerts, and workbooks. Mini review. Azure Monitor equals metrics, logs, traces, and integration with insights and analytics. What is Application Insights? It is an application performance monitoring feature within Azure Monitor. It helps developers detect, triage, and diagnose issues in applications. What does it track automatically? Request rates, response times, failure rates, dependencies, and exceptions. What can you add manually? Custom events, metrics, and traces from your code. What about distributed tracing? Application Insights correlates telemetry across services to follow a request end-to-end. Exam tip. You should know how to enable application insights in app service and functions. Mini review. Application insights equals request tracking, exceptions, custom telemetry, and distributed tracing. What is log analytics? It is a query and analysis tool for logs collected by Azure Monitor. What query language does it use? Kusto Query Language, or KQL. It is SQL-like but designed for telemetry data. What can you do with KQL? Filter logs, aggregate metrics, visualize patterns, and create dashboards. Example, to count failed requests in the last day, you might query requests, where success equals false summarized by count. Mini review. Log analytics equals KQL, queries, insights, and custom dashboards. What are diagnostic settings? They allow you to send resource logs and metrics to destinations such as log analytics, event hubs, or storage accounts. Why configure diagnostics? To retain logs beyond default periods, to analyze in detail, or to integrate with third-party systems. What are alerts? Notifications triggered when metrics or log conditions are met. For example, alert when CPU usage exceeds 80% for 5 minutes. What actions can alerts take? Send email, SMS, call a webhook, or trigger an automation runbook. Mini review. Diagnostics root logs, alerts notify issues, actions respond automatically. Monitoring is not only about performance, but also about cost. Developers should know how to monitor and optimize costs. What is Azure Cost Management and Billing? It tracks usage and spending across subscriptions and resources. What are cost optimization practices? Shut down unused resources, apply auto-scaling, choose correct pricing tiers, and monitor consumption of functions and app service. Exam tip. You may be asked how to minimize costs in a given scenario. Always think about scaling and pricing tiers. Mini review. Optimization equals right-size resources, auto-scale, and monitor costs. How do you troubleshoot in Azure? By combining logs, metrics, and direct debugging tools. What is Live Metrics Stream? It shows live telemetry of your app in real time in Application Insights. What is Profiler? It helps you find performance bottlenecks in your code. What about Snapshot Debugger? It captures stacked traces and variables from production errors without stopping the app. Mini review. Troubleshooting equals live metrics, profiling, snapshot debugging, and analyzing logs. Scenario 1. A function is timing out. Solution: review application insights logs, analyze dependencies, and check scaling. Scenario 2, a web app has slow response. Solution: use application insights to check failed requests, then profile for bottlenecks. Scenario 3, an unexpected cost spike appears. Solution: review cost management, check auto-scaling rules, and optimize consumption. Scenario 4, you need alerts for database failures. Solution: configure diagnostic settings to log analytics and create alerts with email actions. Mini review. Scenarios prove monitoring is about detection, analysis, and response. Best practice 1. Always enable application insights for production apps. Best practice 2. Use KQL queries regularly to understand trends and anomalies. Best practice 3. Configure alerts for critical metrics such as CPU, memory, error rate, and response time. Best practice 4. Monitor costs continuously and implement budgets. Best practice 5. Automate responses to alerts when possible. Mini review. Best practices equal proactive monitoring, regular analysis, and automated responses. Review time. Monitoring and troubleshooting may be only 5 to 10% of the exam, but they are important in practice. Azure Monitor collects metrics, logs, and traces. Application Insights tracks requests, failures, and telemetry. Log Analytics uses KQL to query and visualize data. Diagnostics send logs to destinations. Alerts notify and trigger actions. Cost optimization requires scaling, right-sizing, and monitoring usage. Troubleshooting uses live metrics, profiler, and Snapshot debugger. Scenarios connect theory to real problems in Azure apps. Final message: monitoring ensures reliability, troubleshooting ensures stability, and optimization ensures efficiency.